Hi, Physical Science. Aninga/Manday here, wanting to help you out with some mole conversions that you'll probably see today and probably tomorrow as well. We learned about moles yesterday, what the number is, and how to find like the molar mass of stuff. Here I want to talk about mole conversions, like converting something into either molecules or atoms, or taking that amount of atoms and molecules and going to moles, or even taking grams of a certain amount of something and turning that into moles. Okay? So let's get started. So we have our first conversion, which is moles to grams. This is how many grams are in. So our first question is how many grams are in 3 moles of sodium chloride? Okay. The way you can go about thinking about this is first you need to find how many grams are in 1 mole, or the molar mass of NaCl. Okay. We know that sodium is 23 grams per mole and chlorine is 35.5 grams per mole. Since there's no numbers, that means there's one of each, so we just add those together to get a molar mass of 58.5 grams for 1 mole of sodium chloride. Okay, from there you can write it as a fraction. Remember, since it's a whole number, it's over 1 mole. Okay. Then you just multiply it by the number of moles that you need. So moles here with your conversion factor here, moles here and here will cancel out, leaving 3 times 58.5, which is 175.5 grams. Okay, these moles cancel out. All we basically did was go 1 mole of sodium chloride is this heavy. We have 3 of them, so we might have to take this times 3, which is that. Okay? Here's grams are in, how many grams are in 4.5 moles of water. Again, we find the grams of 1 mole of water. We found that out yesterday to be 18 grams for 1 mole. You can write that as a fraction if you're to do unit cancellations. Put everything into your equation. So we have 4.5 moles times 18 grams per 1 mole. Your moles will cancel out and you'll get your answer of 81 grams. Okay? So hopefully so far it's not so bad. There's how you do the math and the unit cancellation there. Oops, sorry. So 4.5 times 18 divided by 1 is 81.0 grams. Alright, then we'll go from grams to moles. So how many moles are there in 59.0 grams of HCl, or hydrochloric acid? First, like always, you find the molar mass of 1 mole of hydrogen chloride, or hydrogen monochloride, sorry, or hydrochloric acid. We know that hydrogen is 1 gram per mole and chlorine is 35.5, so overall the molar mass is 36.5. Same as before, write it as a fraction, 36.5 grams per mole. And multiply given by fraction. So you'll flip the fraction if you need to cancel your units. So since we have grams on top here, we need to have grams on the bottom for the next one so that they can cancel out. So the 1 mole goes on top this time. As you can see, this will cause our grams to cancel out. leaving moles as our unit to go to the end. We're basically just dividing how many grams that we got by how many 1 mole is, so that we can say that there's that many moles, which turns out to be 1.6. Okay, here's another example of barium hydroxide. So again, find the molar mass of barium hydroxide, which with the math here comes out to 171.3 grams per mole. And we are given 432 grams of it, so we're supposed to find out how many moles are in this. So you write that as a fraction, and then you put this in front. Just like this, your grams will cancel out, leaving moles to go to the end. It's just 432 times 1, and then divided by 171.3, and that will get us 2.5 moles. Okay? Alright. Then we'll do our moles to atoms or moles to molecules conversions. This is where we're looking at how many molecules are in 3.2 moles of a certain compound. We're going to be doing carbon dioxide in this example. So we're given moles, and we're supposed to find molecules. This is where you have to remember that 1 mole is equal to 6.02 times 10 to the 23rd molecules. Okay? So, that is 1 mole. So you need to multiply your given by fraction to cancel out units. Okay? So we want to find molecules, so we got to make sure that that is on the top. So, and moles is going to be in the bottom on our conversion factor. So we have 3.2 moles given to us, so we write that down first. And we times it by our conversion factor, which is going to be 6.02 times 10 to the 23rd molecules per mole. Moles are on the bottom here and on the top here, so they will cancel out, leaving molecules to go to the end. We're basically just saying, if this is 1 mole, let's times it by how many moles we have and get the number of molecules. Type that all into your calculator, making sure to use brackets on both sides of the 6.02 and at the end here after the 20 to the 23rd power to properly get your answer. So your answer is going to be 19.264 times 10 to the 23rd power. But if we move the decimal place over, because scientific notation has to be between 1 and 9, it can't be 19, we just move the decimal place over, adding another number over here, so this number has to go up by 1. So it's 1.9 times 10 to the 24th molecules, because moles cancel out. And that should do it. I'll cover this stuff later. So you'll probably be doing mole conversions today and tomorrow. So we'll be looking probably at the first 2, which is grams to moles or moles to grams, in today. And tomorrow tomorrow and the next day you'll be covering moles to atoms or molecules and vice versa. Okay? Good luck, physical science. Let me know if you have any questions and I'd be happy to help. Alright, bye.